All right, let's get into it. So today, we're going to do what we had to do last time, which is slices. And so I kind of explained slices last time. Oh, actually, let me go post the lecture on the Discord, because maybe there's some people who haven't seen it yet, because it seems like we have low attendance right now. Let's put it up in announcements and say, hey, students. There we go. Okay, so today, slices. So what is a slice? Right? Right? A slice is it's basically a substring or sublist that we can extract using some Python specific notation. And notation. And the thing about it is that when you do a slice, how are you going to do it? So here's the notation. So if you have some list, say my list, and of course you should avoid using a variable called list, and the reason for that is that it actually redefines the built-in list property, so you want to avoid that. So use something like my list or test list or example, right? So that's just a little hint about variable naming. So if our example is say, and I did this before, like 0, or let's do a string A, B, C, D, E, F, G, right? And let's say I take example, and then we go from say 3 to 6, right? For example. So what you do is you find the third character. So remember, it's always 0 index. So 0, 1, 2, 3. And so that's D. And then you take E. And then you take F. And you don't take G. And the reason why you don't take G is that just like in a lot of other list, array, whatever, instances, examples, whatever, instances, we 0 index, and also the end is not included, right? So the reason why we do that is so that, for instance, here you can take a slice from, say, 3 to the end, so this would be 3, 4, 5, 6, but this is 6, right? So you don't include that. But if we wanted to, so how do you include the last character, right? How do you include the last character? And the answer is you would have to do example of from 3 to 7. And you see the problem here, right? So this is D, E, F, G. And so the issue is 7 is not an index, right? So if you put example of 7 in there, you're going to get, what are you going to get? Probably index error, right? Probably, right? And so because of that, that's why we don't go up to this character, or this number, because it's always it's the last thing, but we don't take it, okay? So that's how slices work, at least with strings, and it's the same with lists. So we have my list is equal to, I don't know, let's make it short, A, B, C, 1, 2, 3, right? Something like this. Maybe, I don't know why I'm putting the numbers in strings. I shouldn't be doing that. So 1, 2, 3, 4, 5, 6, 7. Okay, so let's do some examples. Actually, let's just switch over and code them. So let's actually just dump them into a Python file and run it. So slicing. So slicing, let's see. So let's make our example equals to A, B, C, D, E, F. Say G, and then print out example 3 to 6. And let's just prove that I'm not insane. So you see how here it just has D, E, F, right? So it starts at 3, goes 3, 4, and index 5. It does not include index 6. So then if you want to print out the other one, then you have to do 3 to 7. So that's D, E, F, G. And of course, remember that 7 is not an index. So if we actually tried to do that, if we said print example of 7, more than likely we'll get an index error. There we go, string index out of range. And it's the same thing with lists. So as I was right about to get into, my list, right? So that's why I want you not to name things list. If you name things list and you set list equal to, right, some list, something like this, then the problem is if you use list, now Python has to try to determine whether you meant list or you meant list, right? And they're spelled the same. So that's a problem. So don't make Python do extra work. Don't make it think too hard. And it's even trying to warn you here. It's saying Shadow's built-in name list. It's saying don't do that. So here's my list. So now let's do my list from, say, 0 up to 5 and see what happens. Let's print it. Actually, you know what we can do? Even better. We can say x and y, and we can say for I, or no, while s is not equal to quit, right? Our standard thing, and then we say s equals input. What are we going to input? We're going to input give me 2 numbers, and then we're going to print out my list from x to y. We'll say s.split. So there is a nice feature where you can do this in Python, but I haven't really taught that, so instead what we're going to do is we're going to say split string equals this. Split string 0 int equals x, and y is equal to split string 1, and then we'll go through again. Okay? Oh, we should split it and do this calculation here, and then here we have to prime the input. Okay, let's do it again. Whoops. Oh, right. Comment that out so that we don't end up with something like that. Okay, so give me 2 numbers. Let's say I do 0 and 5, and then let's think about how this is going to work. Right, so what this is going to do is it's going to take from 0, 1, 2, 3, 4, and then are we going to see 5? The answer is no, because remember, it goes up to the index but not include, right? Up to, but doesn't include the last index. So let's see what happens. Hopefully this works. There we go. Let's say we go from, say, 1 to 6. Let's see. Hopefully we'll actually get 1 to 5 now, right? Let's say that we slice from 2 to 8. What happens? So notice here that it doesn't include the last one because remember, how long is this list, right? And without taking len, you can tell how long this list is because it counts from 0 to 8. So you know that there's 9 elements in the list. So the length of the list is actually 9. So let's say we go from 5 to 9. Right, so this is 5, 6, 7, 8, and it gets to the last element and it takes it. Okay, so here's some other things that you can do with slices. What if I enter 9 and 2, right? So what if I try to go backwards? So I'm trying to put, for instance, what I'm trying to do here is put in, and maybe I'll do this here. Let's do 9 and 2 like this, just, you know, just to show as an example. So what happens when you print out my list from 9 to 2? Well, when we did 2 to 9, or let's actually do 2 to 9. 2 to 9. Okay, that's what we get. Are we going to get the same thing? Are we going to get it reversed? Or what are we going to get? Here's what we're going to get. Empty list. And so you might be asking, why did we get the empty list? You know, why is this an empty list? Rather than the 2 to 9 reversed, or something else like that maybe. Why did it give us empty? And the answer is that there's, basically the secret answer is that there's a step argument. The real answer here is that when you just use a 2-argument slice, so 2-argument slice, so when you have x and y, like this, this means that x has to be less than y, because it steps up by size of 1 each. Okay? So that's what it's doing here. Okay? So the 2-argument slice means that x is less than y. There is a 3-argument slice that I might cover later, or I might just not cover. We'll see. You know how it is. Okay, so that's the point here, is that if you enter something in the wrong order, so if we put in, you know, say 5 to 3, whoa, oops, always have to put in 2 things. Remember, it's very specific, it's very finicky. So 5 to 3 will give us this, but 3 to 5 will give us this. And so you see that, you know, it requires it to be in the correct order. I think that's basically all I'm really saying about this. It's just a little weirdness about slicing, because you might think this would work, but it doesn't. Okay, so let's do some more slicing examples. So let's see, what are some more slicing examples? So you notice that I used like single numbers here, and for instance here I just used a string. You can have complicated things in your string or in your list. So if you have like test list is equal to, you know, hello rabbit flavor pants, excellent. Tomorrow, I'm just making up as many random words as I can that are totally unrelated. Sang maybe. Anyway, okay, so there's a good list of words. You can do the same operation here. So if you do test list from, say, 3 to 5 or 3 to 6, right, and we print this out, this is a list of strings, remember? So what's going to happen here? Let's actually let's skip the while loop there. So okay, so you see here that this thing is actually it's taking 0, 1, 2, 3. So it takes this one, takes this one, takes this one, and that's how it works. So as it turns out, this this slicing feature is pretty useful. There have been some questions about whether it's allowed on the midterm. So here's what I'll say. You can do the what problem is it? It's the Pig Latin problem, either with slices or without. Now that I've taught them, I know that you only have like really, well, I guess you have like 3 days to rewrite it if you want to, but you can. I'll legalize. Technically, they're illegal right now, forbidden, but after today they'll be legal. So you can use them on the exam. You know, if you find a way to do it. I wrote my solution without it, so it is totally 100% possible to do just with loops if, you know, while, like for loops, if, you know, 5 loops, yeah. Right, it's totally possible. My solution was written up totally without slices, so okay, so what other kinds of things can you do with a slice? Good question. You know what, let's talk about the third argument. Is there anything that I could legalize for word search? What is word search? No. So, word search, on the other hand, is just loops. My hint is that I used, I think, 3 nested loops, something like that. So, basically, I think, you know, so, okay, so here's some hints for word. I know this is off topic, but I'm sure that there will be less complaining. How do you search for a substring, right? So let's say that we have a big block of text, and you say, hello, I am a big block of text. Find something within me, and, you know, you will profit. And so let's say that we're going to look for text. Whoops. Right? Now, so this is not the problem, right? This is not the solution. This is definitely a simplified version of the solution. This is definitely not exactly what you're doing. But you're going to have to, my hint is that you're going to have to play with indices. Play with indices. And what I mean by play with indices is that you might say something like for I in range len big block of text, right? And how would we check if this is the start, right? We're not going to check for the whole substring right now. Let's just check to see if something is the start. So if, say, look for at 0, right, is equal to big block of text at I, right, then we'll print out I, right? Let's see what happens. Okay, so there's going to be some garbage beforehand, but I think it'll be okay. Okay. So we look at this thing and we say, I guess T and T, right? So this must be 26, 27, 28, 29. So those are those two numbers there. And then we go for a while, and then here's the within at 41, I presume. And then, oh, sorry, no, this must be the 41. Something. And then within is 49, and then profit is 75, right? And so what could you do if you knew that there was only, let's say that we know that the length of the string is only 4, right? So this is, again, the 35th rule of acquisition. Oh my god. Very good. You almost succeeded in derailing this entire lecture and making it into my lecture on Star Trek, but I will not do that. So, okay, so this is not how to do it, right? So this might be how to do it. This outer for loop might have something to do with it. This inner if statement stuff is just for an example. So don't try to force this into your code. It'll not be happy. But try to understand what I'm doing. I'm trying not to give too much of a hint, whereas also giving enough of a hint so you understand. So if look for 0 is big block I, and if look for 1 is equal to big block I plus 1, right? And I guess we should also check if I plus 1 is less than the length of big block of text. We're going to have to do that a bunch, right? Then what we can do is then we test if print found T at I, found, what is it? What are we looking for? Text. E, I plus 1, right? And then we'll say, like, if I plus 2, right, is less than the length of the big block of text, and look for 2 is equal to big block of text 2, then we'll print found X at I plus 2. And then finally, if, and of course, you kind of get the point of why this is horrible, but I'm trying to not give out the answer, right? So this is my attempt to not give out the answer, but also give a useful hint, right? So, and then we print found T and the whole word. word, right? And then what we can do is, so we can find the whole word. And then we'll print out I+3. Okay, so let's run this thing and see what happens. And now you see that this piece of code right here is extraordinarily bad, in the sense that, and you might be thinking, well, it doesn't look so bad. Well, you should be thinking it looks pretty bad, but let's assume that you don't think that. Why is this piece of code bad, right? It limits us to only checking for exactly length 4 blocks of text, but here we're doing 0 and I plus, I plus 1, I plus 2, I plus 3. So there's a way, right, that you can kind of make this work. Think about what this is, right? This is a whole bunch of repeated if statements. Well, there's a way to get if statements to repeat without just doing this, right? There's a way to do that. So, okay, let's run the code and see what happens. Yeah, it might be a loop. Who knows? It's the only thing we really know. So, let's see. Have I coded this correctly, or have I made some screwed up thing? Oh, no, look, Oh, no, we don't care about efficiency in this class. The only thing that is important is that your code should... I guess the exception to that is that your code should run in a reasonably... So what I'll say is your code efficiency isn't important. If you were really doing important efficiency, then you would use like a suffix array or some kind of advanced data structure for string matching, or you'd use like Knuth-Morris-Pratt, right? What I'm telling you is don't even look up any of that, right? That's way too complex. That's if you want to match stuff with like 1 million characters in it, right? You use advanced string matching for like genetic algorithms that are running on DNA sequences of like 3 billion, not on strings that are length 20, okay? But when I say your code needs to be reasonably efficient, what I mean is that it must run in the amount of time it takes for a grader to give up and hit Control X or C or whatever, right? So that's what reasonably efficient means in this class. So it just has to run, and if it's going to take a long time and the grader knows that, then they might wait 5 seconds. But if they're sitting there and they're waiting 30 seconds and they're like, oh, your program is in an infinite loop, and they kill it, then that is unreasonably efficient or reasonably inefficient or something like that. Either way, that's bad. So just, under 5 seconds runtime is good. Is okay. So, okay. Basically, the point is here, there are way better ways to do string matching. I don't want you to look up any of those. I want you to bash out, like, the most simple kind of dumb solution that you can think of that works and get it down into code, because I don't want you to be doing something that's really complicated, because you can... Save that for algorithms at the 400 level, right? Anyway, so here's some if statements, and you notice that what happened here is that first it found the T, right? And then it advanced 1 index, and then it found the E, and then it advanced 1 index, and it found the X, and then it advanced 1 index, and it found the last T and the whole word at 29, right? Yeah, exactly. So, that's how this string matching algorithm works. Now, my hint to you is that this should probably be a loop somehow. So make this into a loop. And then you're also, so the only difference is once you fix that, so that's my hint to you. So my real hint for this problem is, now that I've done that bit of code, make it work for multi-length match strings, right? So that's the first thing that you have to do. And then the second thing that you have to do is make it work for, what should I say? And when you do the offsets, right? So the offsets are the other thing that you have to do. How do you do those? My hint to you is, don't worry or no, I'm sorry, not offsets. Offset, I here is the offset, right? I is equal to the offset in this case. Really what I wanted to talk about is gaps. How do you do those? And the answer is that, well, good question. How do you do those? The answer is don't bother with them until you get the string matching working with just offsets, no gaps, right? And then think about like how this is going to work, right? Let's say that I, instead of having text in here, I have ta, right? That's, we have this word here, but we know that text is here with a gap of 2, right? It starts here, E, X, T, and I just shoved in A's just so that there'd be letters in the middle. And so my hint to you here is that here instead you would do I plus 2, right? If you're looking for a gap of 2, I plus 4, I plus 6, right? And so clearly what you're going to have to do is you're going to have to do some kind of, at all points, you're going to have to do some kind of index manipulation, some index modification to see what's going on. So let's see what happens here. Nope, I'm not going to give you 2 numbers. So, interesting. Oh, because we're outputting, I'm sorry, you see we're outputting the old numbers. So this is I plus 2, I plus 4, I plus 6. Okay, that confused me for a second. I was like, how is that possible? So here, T is still found at 26, E is found at 28, X is found at 30, and the last T is found at 32, right? And you see that's at index I plus 2, I plus 4, I plus 6. So this would be a gap, right? Gap of 2, right? And let me just copy paste. Well, yeah, let me just copy paste this, and then we'll rename these or redo this so that this is the original, and then this is just 1, 2, 3, 1, 2, 3, 3, 2, 1. Okay, and 2, 3, 1. Whoops. Okay, so that's it. So I think I'm going to make slices illegal for this problem. So don't use slices. And I know that you might think, well, isn't that unfair? And the answer is yes, a little. But the reason why I don't want you to use slices is this. Because most languages don't have them. And because most languages don't have them, the solution that I want you to come up with is the more general programming type solution. It's what the slices are doing underneath the hood, right? And so the point of this course is not to teach you all the most advanced features of Python, right? We don't do the absolute most cutting edge Python features that have just come out. And the reason why we don't do that is because we are supposed to be teaching programming. We are not supposed to be teaching, well, I mean, we are supposed to be teaching Python, but we're not supposed to be teaching Python-specific programming in the sense that when you get to C++, we want you to understand how to do these things again without any of the extra features, right? And so that's, C++ won't have these features. Yeah, I mean, the problem here is actually this is, maybe I'll even have you redo this problem with slices on the next homework. That's a good idea. So do it without slices on this problem, and then the next homework will be with slices, maybe, theoretically. So let me talk about the step argument in slices. You're not going to have a lot of use for it. So let's talk about steps in slice. Slice steps. Okay? So the slice steps are the third argument. Normally a kind of secret, what we would call a default argument. And so it defaults, the default step is equal to 1. So here, So the default step is equal to 1, and that's why we get things like we see. But let's say that we actually want to take a string, and let's say we have, I don't know, let's say a string, right, is equal to ASDF. And so I hope I did that evenly, and the reason why I hope I did that evenly is I'm going to print out a string, and then what I'm going to do is print out a string starting at 0, 0 going to the length of a string, right? And then I'm going to put a step of 4 in there, and I want you to watch what happens. So let's see what happens if we do a step of 4. And so here what you see is that you have ASDF, so that's 0, and then you have index 1, 2, 3, and then here's index 4, that's another A, 1, 2, 3, or really it's, what, 4, and then 5, 6, 7, here's index 8, right? So it's a lot like, what should I say here? It's a lot like if we had a list, so let's do a for loop, I in range, say 100, and let's just do my 100 equals empty list, my 100 dot append I, so let's just stick all the i's in there, and then here what we're going to do is we can print out, for instance, if I want you to print out all the numbers that are divisible by say 3, what we can do is : 3. And so this is, so let me explain what this notation is. There's a bunch of default arguments in slicing. And so if you don't fill the first argument in, it gets set to 0. Okay? So that's how it works. If you don't fill the last argument in, or don't fill the second argument in, it gets set to the length of whatever it is, right? The length of the string or list. And if you don't fill in the third argument, it gets set to step equals 1, right? So the point here is that what we're doing is we're starting, this is the same thing as doing, well, actually, let me just prove it to you, right? Why say it when you can just make it happen? So let's run this thing and see what happens. So, okay. So you see that these two lists are the same, and the reason why these two lists are the same is because, just as I say, if you don't fill anything in here, so if this is blank, it fills itself in with 0. If you don't fill anything in here, it fills itself in with either the length of the string or the list, right? Just len of whatever. And then this is the step argument. Now, if we did blanks for all of them, like this, we would see that, I think it would, yeah, so this just makes a complete copy of the list. So, right, so basically this is the same thing as doing 0 to the length of my 100, which hopefully is, what, length 100, and this, right? This is the same thing as, in fact, why don't we just print it out? Is this thing the same thing as this thing? And the answer is true, right? That's nice, right? So, true. Nice, okay. So what else should I talk about with slices? I guess the last thing that I really want to cover with slices. And so for now, don't use negative indices in slices. You can, or I should say negative step. Negative indices or negative step in slices. I'm not going to teach it this semester, and just be aware that you can do that. Like, you can use negative numbers in slices, and you can use negative step in slices, but that's for your future life outside of this class. For now, let's just stick to this. I think this is enough in terms of slices to confuse everyone. So here's the rule about teaching slices. Slices end up confusing just about everybody. And I think somewhere between 25 and 50% of the course, of the students, end up saying splice and not slice, and 25 to 50% of other students end up saying, what is a slice? We never learned that. So for some reason, I noticed that this topic, for loops people remember, while loops people remember, if statements people remember, slices, it's like I never said anything. And this has happened for about 3 semesters now. So just try, here's what I'm going to say. After you finish your midterm, play around with slices, right? Just get comfortable with them, okay? Just open up PyCharm or open up and just play around with them until you understand them. That's the only way you're going to actually understand them. Do not just use the lecture, do not just listen to the lecture and be like, oh, I get it, this is easy, and then never touch it again. Because, yeah, exactly, I sure love splices. So, yeah, the point is that, but the point is that I don't really care if you call it a splice. It's technically called a slice, but I've heard splice used so much that I really don't care. This is the one I don't like. This is the one where I think that people take what you hear in the lecture, and I'm sure that the people watching live are not the ones I'm talking to. I'm talking to, if you're watching this 2 weeks from now, I'm talking to you. I'm saying, hey, play around with this stuff. Do not just assume you know it based on watching me type, right? That's the worst thing you can do with coding. And I mean, it's true with all programming, and it's just a little, just a little PSA. Don't assume you know it because I knew it in lecture, right? And that it's a big assumption, right? Because you saw something and it made sense to you in lecture, but it's like the difference between being able to hear a language and being able to speak a language. So you have to practice. Okay. So that's basically it for slices. I don't want to do too much more. The only reason why and then one last thing about slices. The very last thing about slices. Very last thing before we go into dictionaries, which I'm actually going to get to talk to. Slices make copies. Okay, slices make copies. They do not, so they don't just make references to the old object. And let me prove it to you. So let's have my list is equal to, say, A, B, 1 to 17, that's 16. 17, 21, 33, 91, C, right? And so let's say that we take a MyList slice from, say, 4 to 7, right? And so we can say new slice equals this. And then what we're going to do is we're going to say new slice 0. Well, first let's print out the new slice. And then we're going to say new slice 0 is equal to, I don't know, 25, right? So and then we'll print out the new slice, and then we'll print out the my list again. Print my list, right? So if this were a reference, if this is basically pointing to this list, then what it's going to do is it's going to actually modify it. But let's see what happens here. So you notice here that the slice, right, took from index what? It took from here to here. So the question is this variable, is this thing pointing to a little 3-sized sublist of this thing, right? Is it actually is it making a copy of these elements, or is it just saying, oh, I have a new index of 0, but my index of 0 is the same thing as your index of, what, 4? Yeah, so your index of 4 is my index 0, your index 5 is my index 1, your index 6 is my index 2, and I have no more indices, and I don't care if you do or not, right? But the answer is, if you look at it here, this was modified. This changed to 25, whereas this was kept as 17, right? So basically, what am I saying here? What I'm saying is that slices make copies of lists and of strings, though with strings, since they're immutable, we gotta, say a bunch more nonsense, right? With strings, it's much less noticeable because you can't modify strings. You can create new strings based off of old strings, but you can't actually modify a string, right? Because you can't do... Would it have made offsets easier? Yes, it would have. That's why I'm banning it. You cannot use slices for that problem. I know that it sucks, but I just want you guys to get practice doing it without slices, because it's a bit of programming problem solving that you should think about. It's not something that you should just glance over, right? It's something that you should know, right? So, and plus most languages, I know. So, okay. And so slices make copies. And so it's very easy to run out of memory if you make too many slices. Like if you have a say, length 1 million string, so for x in... let's not even do it. But just take my word for it that if you make a big enough string, and you take 100,000 or a million slices out of it, you may run out of RAM. That's the real concern here. So now, of course, in this class, so for 201 problems, you'll never see data that large. I mean, and the star means unless I'm losing my mind or something, right? So we're not going to give you any kind of, unless it's something that's extraordinarily specific, and I'm like, well, we really need to use a length 1 million string. You're not going to see length 1 million strings. The answer is probably 341 is when you start to see large data. And I'm not saying big data. Not big data. I hate that. So, but the point is that, yeah, you'll start to see large quantities of data, or I guess big data, when you get to 341. Though most of the times, even then, you'll test on things that are way smaller than size 1 million. Anyway, so my point is that, yeah, so wait until 341 until you see something like that. Okay, cool. So yeah, slices do make copies. And so the ultimate last thing before we get to dictionary, the large data is a word I invented just now. Big data is like a buzzword. So yeah, you see, large data is bigger than big data, or something. I don't know, that it doesn't make sense. Okay, so, all right. So the last, I know I said that was the last thing that I wanted to say, and it is the last thing I want to say. But there's a subpart B to the last thing that I want to say about slices, and the very, very last part B part of what I want to say is this. So you can make a copy of a list. So if you have my list, let's see. Yeah, so if you have a list, you can... My copy list is equal to list of my list, right? This will make a copy. But now you know a second way to make a copy. My slice list is equal to my list empty slice, right? If you do an empty slice, we'll also copy a list. Interesting, right? So these are two different ways to copy a list. Which way do I prefer? I actually like this way better, just because I think it's less gimmicky. It's it tells the other programmer, oh hey, you're making a copy of this list. This one, for people who are coming out of other programming languages and coming into Python, they're going to look at that and they're going to be like, what the heck is that, right? So, but again, in Python, this is the cute way, and this is kind of the, it's like the cute way, gimmicky way, and this is like the maybe constructory way. That's right. That's basically right. So, okay, so that's all I want to say about slices for now. And So let me not say that this is all there is to say about slices, right? There's a lot to say about slices. There's a lot to say about, all of this stuff, except that I'm trying to give you just what you need to know for the course. And if I give everybody too much, then I would just confuse everybody even more. So slicing is pretty horrible. I just want you to get practice with it. Just make some lists, slice those lists, and print them out. Right? That's what I want you to do. Okay. So now let's move on to dictionaries. So we're actually going to get to talk about dictionaries today. And so, what's a dictionary? What is a dictionary? And I'll probably do a little bit more on dictionaries when we get back after today's Wednesday, and then I guess next week is spring break, and so I'll do more on the 22nd, I guess. So we'll talk about this more. This will not be the last time that you see dictionaries, but I just want to introduce them now. So let me just say that don't use dictionaries on the exam. Okay. I don't think they're going to help you. But don't use them. So as I say, I don't believe that there's any problem that's like screaming out for a dictionary. But if there is, avoid it. Okay, so what is a dictionary? So the answer is a dictionary is it's actually, in most programming languages, it's actually what's called a hash table. In Java, I think there are hash tables, and there's also hash maps. In Java, they go by different names. In Ruby, they're just called hashes. Normally, the term hash is applied at some point. So most languages will say hash. And the reason why they do that is because a dictionary, secretly, it's a big array. List. But for us, what it looks like, at least to the end user programmer person, it looks kind of like a map. But I mean a map in the mathematical sense. And so let me show you what I mean by this. So let me show you, so here's our first dictionary. And you use the, instead of using the square brackets, you use the curly braces. And so basically, instead of storing one thing in each slot, you basically store two things. So let's think about how to do this. Let's say that we're going to store people, like, so here's Eric. Let's store 17, right? Let's see. Vendor 51. Fry 2. I mean, I don't know what these numbers mean. These absolutely, random numbers, but who cares, right? So, and then 99. Okay, if I can type. So, okay, so let's print out. So this is making an empty dictionary, right? Empty. Our first empty dictionary. And here's our first actual dictionary, right? So what if we print this thing out? Let's see what happens. So it's going to print out much like it looks right here. And so let me explain what all these things are. So basically what these are key value pairs. And what I mean by that is that the dictionary is accessed via keys. And when you do that, it gives you back a value. Okay? And so here what we're doing is we can say our first dictionary, and instead of putting a number in here, right, like normally if this was a list, you would put our first dictionary 0. Here you're going to actually type in the key value. And so let's print this out and see what happens. And let's print out Fry. And then let's print out, say, Zoidberg. And And let's see what happens when we print all these things out. So you notice that what happened is you plug in a string and you get the number back, right? So basically, based on the key, you can get the value, right? So one way to think about this is it's not always string int. So just in this example, it's string are keys and int are values. But it can be anything, right? The keys, yes, the keys always come before the values in the declaration. So basically this is key, value, key, value, key, value, key, value. So for instance, if you want to look at the keys of your dictionary, you can actually print out, say, our first dictionary dot keys. And that'll give it to you. There we go. And now it prints it out as this weird dictionary keys object. It's basically a list. But not 100% entirely quite a list. It probably has some extra functions in it. Let's see, what has it got? I don't know. So, point is, who cares, right? It's more or less a list, and if you ever need it to just be a list, you can just cast it to being a list like this, so that it won't display that dictionary keys thing, but it really doesn't matter, so that's not important. And if you ever need to print out the values, our first dictionary.values, you can use this function. So here's my hint, is that generally you're not going to be using these functions very much. You're not going to use these much. At least I don't like them. They're kind of, it's okay, but probably not the real reason you're using dictionaries. Okay. So, do the keys always have to be strings? No. So, for instance, here you can have, let's say, number dictionary. And let's say that we have 3 maps to 15, 4 maps to 17, 22 maps to 31, and 81 maps to 5. Right? Can you iterate through a dictionary? That's a good question. So let me just say keys and values can be any type, except that, and so here's the except that, the keys must be immutable under the Python definition. So examples of immutable things as we go back, right, we got to review what are immutable things. Immutable things are like strings, int, bool, float, tuples, right? So like the immutable version of a list, and things like the datetime object, etc. There are other immutable objects in Python, but no lists as keys. Lists can be values, right? So let me just print out the number dictionary, and to prove that I haven't done anything screwy, right? Here we are. So let me show you why so let me just do a weird thing equals the key can't be a list, so you can't do, say, 1, 2, and then hello there, right? So this is, well, I think this is going to give us an error. So let's see if it gives us an error. And remember, standard error is always in a different order than standard out. So, or I shouldn't say always in a different order, but it is in this case, right? So the unhashable type list, right? Unhashable type. And what is an unhashable type? It means immutable, or it means that the type was mutable so bad, right? And the reason why that you don't want your objects to be mutable is because then if you had, say, my list, right, is equal to 1, 2, or let's say a list is equal to 1, 2, and then instead of that you did a list hello there, right, and then you did a list dot append 3, right, then the problem is, how do you access this value, right? Do you access this value by going weird thing of 1, 2, right? Or do you do weird thing of 1, 2, 3, right? Which one do you use? Because now this list is different. So, you know, what do you do? And the answer is we avoid all of those questions by just forcing the type to be immutable so that you always access the value by the same key. Once you stuck something into a dictionary, you can, yes. So you cannot modify the key values, right? Cannot modify the key values. You can modify the type of the values. That's why I was confused. The values, right? Is that fine? The keys. You can modify the keys value. You cannot modify the keys value. You can modify the values value. So let's do some examples of that before we get too far. So for instance here, let's say we have some kind of address book, right? And so an address book is a good thing, or like a phone book, right? Because like you could always just look someone up by their number, or you could look someone up by their name. But let's say that we're going to put them in by their number. So say like, you know, 1, 2, 3, 3, 3, 5, 5, and this will be me, right? So this will be Eric, right? And let's say you have another phone number, or actually we could even store them as numbers. You could just store them as like, you know, 911 emergency. You could store, you know, 223 3232, and that'll be Sam. Yeah, that's a good number. I think 8675309. Who lives there? I forget. Who is this again? I forget. Okay. So basically, this is like a phone book that if you look things up by the number, you could actually get whoever or whatever was at that number. So, so this would be a good use of a dictionary. And the reason why this is a good use of a dictionary, so let's say that there's a new person, right? So let's say that there's a new person. Let's say that, you know, what's a good name? Jill now has phone number 3456789. A very imaginative, original number that no one would ever think of. 3456789 equals Jill. And so let's print out the phone book again, and we'll see what happens. Hopefully I commented out all the errors, hopefully. So you see here that you have a number associated with a name, a number associated with a name, a number associated with a name, etc., right? And I forget, and then this is Jill, right? So how do you add something to a dictionary? So adding something to a dictionary means that you just access it and assign it, right? So you can't just access it the first time. You can't just do something like, you can't access it here and print it, right? If you do that, then it's going to say key error, because that key is not in the dictionary, right? So it didn't like me now, because you notice that the key wasn't in the dictionary on this line of code, so this gives a key error. But this line here will be okay. The reason why this line here is okay is because it's an assignment. It's saying, it's telling Python, take this and assign it into that spot. And so Python can tell the difference between an access of a location and an assignment of that location. And so that's the trick that they're using. So I shouldn't really, should I say Python or dictionaries, or Python can tell the difference between assignment and access, right? So in order to add something to a dictionary, what I should say is you assign it. You don't access it. So don't access it before you've assigned it. That gives key errors, right? Key error just means you haven't put that thing in the dictionary yet, and so you're very bad. The other thing to notice is that it's very type specific. So for instance here, this should also give a key error, right? If we just put this in a string, So even though we had 3, 4, 5, 6, 7, 8, 9 in the dictionary, right, the string 3, 4, 5, 6, 7, 8, 9 doesn't get converted. So be careful with type. So everything, yeah, so generally it gets added to the end, but the thing about dictionaries is that they're kind of random jumbles of order, so they don't really have a preferred order. So that's one important thing to say. Dictionaries aren't like lists. And the reason why they're not like lists is they don't have a preferred order. So you aren't actually guaranteed. So let me actually, and this goes into the iteration question. So same thing with the iteration question. You know, how do you access like all the phone numbers, right? So let's say for phone number in phone book, right? So what's going to print out here? Let's print out the phone number right here. And so let's see what happens. So notice here that we only get the keys, right? Only the keys print out. So that's why you'll notice that some people do something like this, but you'll notice that that's not actually necessary, right? Because if you just iterate through the phone book, you don't have to call this .keys method. You just do this. The dictionary object will sort it out for you. So this object itself is iterable, so that means that it'll spit out keys, okay? But then you might ask, right, so your next question is, but wait, how do I assign, or not assign, how do I access the actual value then, right? Right? Because if the for loop is going to give you the key, then how do you get the value? So the actual answer is, if you want to know that, if you want to do that, then you have to say, for phone number in phone book, you print out the phone number, and then you have to access the phone book at phone number, and that'll give you the value. So this will give the key and the value. So you don't actually have to get the key, right? You could just do this, but I like printing them both out just so that it's clear. So this gives both keys and values, okay? So, right, and so here we see, here are just the keys from the first for loop. And then here are the keys and the values printing out from the second for loop. All right. So let's do another example. So let's say that we have a grades book, right? Grade book. A grade book is a good example of what to do as a dictionary because, or, you know, even better. Well, no, I mean, yeah, this is good too. Maybe student records. This is a good example of what to do as a dictionary. So student records are generally stored, you know, under something unique, right? And even names aren't really unique. Like if we look for, you know, unfortunately, if we look for something like a James Smith or, you know, things that might not be the most popular name, but if we look for someone named James Smith, there is probably more than one who graduated from UMBC, right, since 1970 or 1990 even, right? Possibly, right? It's not impossible. So, you know, you wouldn't want to use the names. So names are, in that, if you're going to store all the student records, are there things like remove and slicing for dictionaries? There's not really slicing, but there is remove, and I'll show that in just a minute. So the names aren't really unique, but so names bad. And the reason why names are bad because you wouldn't be able to store both James Smiths, right? But like student ID, right? Great unique identifier, right? UID stands for unique identifier. And the reason why student ID is a great identifier and the reason why they exist is because if you think about it, it's kind of the reason, well, so people, you know, we used to just use social security numbers like 10, 15 years ago in colleges and stuff like that. But we started getting away from that because we realized that it was a massive privacy breach. So, which I think is pretty legitimate. So, so now we use student IDs. And the reason why student IDs are great is because even if there's 15 James Smiths, right, who graduated from the university, each one of them is going to be given a separate student ID. And so that's how, this is like how you choose, like, what should the key be? And the key has to be something, something unique, right? So either, you know, if you're storing two things under the same key, then that's a problem. So let's say that the student records is going to map from, like, student ID, so say AB 1, 2, 3, 4, I guess 5, and this will be James Smith, right? And of course here, and let's say that James Smith here is a computer science major, but then let's say that there's another student, CD 22112, right? And they are, and I, Will Smith, and Will Smith is a drama major, right? Probably. And then who else should we have here? So, oh, no wonder. There we go. So who else should we do? Let's just do EF, G, 1, 2, 3, 4. God, John Smith. Well, John Smith, and he is a naval architect. Or something, whatever. So, okay, please reformat this for me so you stop yelling at me. Okay. Okay, so we see here, and then the whole point here is that we have to make another James Smith. So let's do JH, some number, and so this is also going to be James Smith again, right? And they're going to be in art history, right? So that's how we're going to do it. So now you see that this is a pretty useful way of storing data, and you notice here I've done a number of examples here. So let's say that yeah, there's a lot of Smiths, and they're all very I don't know, they do a lot of different things. So okay. So the point here is that in student records, right? Student records. So if you do let's say that let's just do this. So print out student records at, say, EFG, or let's EFG 1, 2, 3, 4. And so what this does is it allows us to know whose actual record we're printing out, rather than, and you notice that here the thing is a list, right? So it's an example of the fact that you can actually use mutable things. You can store mutable data inside of the dictionary. It just has to be a value. It can't be a key. All right, so let's answer a question that was brought up, which was how to delete from a dictionary, right? So we know how to add to a dictionary. So there has to be a way to remove from a dictionary. So let's see, how do we do that? So let's say that we wanted to get rid of one of the, let's say that Will Smith drops out, right? So we don't want any more Will Smith in college. So what you can do is you can use what's called the del keyword. So this is the del keyword. And you delete the student records at, CD 22112, something like this. And that's it. So let's print out the student records after that, and just prove that, I don't have anything up my sleeve. Everything is exactly as you would expect. So here we have James Smith the first, and here we have John Smith, and then we have another James Smith, and Will is gone, right? So he's gone off to Hollywood or something. So so the point here is that so this is how to delete out of a dictionary, and it's as simple as that. It feels a little bit weird because if you do delete student records, that will just delete the entire variable. But if you do delete the student records at a specific key, then that will just delete the thing in that key. Okay? Is del limited to dictionaries? The answer is del is not limited to dictionaries. Del works on lists, it works on variables. So here's an example with del that's actually pretty horrible. So let's call my favorite variable is 13. We're going to print it out, prove it exists, and then I'm going to delete my favorite variable, and then I'll print it out again. So, so notice here that for this one, my favorite variable printed out 13, right? And then I deleted my favorite variable. It's gone forever. And then I print it out, and then it says name error, right? Not defined. So somehow between this line and this line, the variable became undefined. So delete will actually undefine variables for you. So most programming languages, so this is a weird feature of Python. Most programming languages don't have, what should we call it? Let's see, most programming languages don't have this kind of feature where you can delete a variable. But Python does. Yeah, we still have about 2 minutes. And so, okay. Oh, right, and then the last question that you asked before we'll go, and remember, we'll do more, let's see. It means that you probably have some kind, if you're on Windows and you hit Control, let's see, what is Control-Alt-L? Or it should fix it up. Python sometimes, it has very specific PEP8 standards, and it should auto-format it for you. It's probably a formatting issue, is my guess. Okay, so the last thing that we wanted to do was talk about modifying elements. So let's say that, let's say that, well, we murdered this guy. So, let's say that James Smith, or let's say John Smith changes his major, right? So here's how you would have to modify it. So you have to. So this is actually a good thing to talk about. So here we would modify student records, right? And we would access their user ID. And then remember what comes out of here, right? What comes out of here is a list with 2 elements. The first thing is their name, which we're not going to mess with. The second thing is their major. So let's say that they're going to become a, I don't know, mechanical or whatever, mechanical engineering, right? Oh, wait, no, that's dumb. I'm sorry, that's not right. So we want to access this as a list. So how do we access this as a list? We're going to access not the 0th element, but the first element. I was too busy deciding what major he was going to be to actually change his major. And then let's print out the student record at EFG 1 2 3 4 and see what happens. And then let's print out the whole dictionary just to see what happens, right? We want to print out, so you see here, we actually did change the guy's major. And so you see that that's kind of the point, right? Is that we can mess with the data. You can always reassign the data, but you can't really mess with the keys. So once you insert something under a key, that key is either in the dictionary or it's not in the dictionary. Like you can remove it from the dictionary or not. But you can always modify the values. So even in other dictionaries, like for instance, if we go back to this number dictionary, right? You can always just do number dictionary, and then instead of saying 3 maps to 15, now 3 can map to 21, right? And this will also modify the dictionary. So let's actually go back and find where. So let's see. Here is the numbers dictionary, right? So this is where it is. And so you see 3 now maps to 21 and not 15. So that's that. Okay, so we'll talk more about dictionaries when we get back from spring break. But I just wanted to introduce them, and we had some time. I think we've done okay in terms of slicing. I think we've done okay in terms of dictionaries. So I would say just play around with slicing. Dictionaries, I think people figure out more easily than slices. I think slices cause much more trouble than dictionaries, but But, play around with dictionaries as well. Try to figure out which things you can stick in as keys, which things that can't be stuck in as keys. Play around with stuff until you're happy with it, right? Okay. Okay, so I think that's all for today. So I will let you go. Let's play the outro. So, okay. So we're not done yet, I guess. Let's see. Hello, there you are. You're not on yet. Let me go to the intro scene. I think I need to turn on desktop audio on something, right? Let's say talk. Say things. Okay, try again. Nope, didn't work. Let's add a desktop audio setting. Yeah, I mean, it's fine, right? Let's see. Create new. Make sure. I don't know what that means, so I'm gonna click OK on that. Oh, desktop audio 2. Almost there. Yeah, almost there. Let's see. How about this? Does it work? No. What the heck? Yeah, I think so. I like how this little bit is going to be at the end. Yeah, I mean, I'm like talking to myself. I'm like trying to get you on, and clearly I'm just not having any luck. I'm a little confused. The problem with OBS is that sometimes it like forgets about settings or forgets about things, and it just doesn't. It like literally just forgets that there's a device, and then you have to like re-add the device. So let's see here. Let's see about this one. How about this one? I wonder. Maybe?
Maybe?
Oh, there it is.
Did it work? Am I on it now?
It did. It worked.
Okay, so this at least absolves you of any sort of, like, talking to a fictitious creature. Instead, it's just me, who might as well
I think
be
you're audible now, so that should be... Now I just have to go in and like delete all of the other desktop audios that like no longer work for whatever reason. It's like completely it's like forgotten about their whatever device they were connected to, got reset or something, and now it just doesn't understand.
Yeah.
Alright, I guess we can end the video now that I figured.
Yeah.
Alright, let's stop.
Now that we've had success.